Hello viewers, welcome to Senior College Mathematics. In this series of teachings, we have College Trigonometry. Lesson 10, Trigonometric Equations. A trigonometric equation is an equation containing trigonometric ratios. Since trigonometric functions are periodic functions, there are infinite number of solutions for any trigonometric equation. Solutions to trigonometric equations are found within a given range. For example, sine. Sine has the wave form nature. So the shape of the sine is always going up, coming down, coming down. So there is no finite solution. The solution are always infinite. But when you work within a given range, then you can obtain the set of solutions in that range. Examples: find the values of theta in the range 0 degrees less than equal to theta less than equal to 360 degrees, which satisfy the following equations. Example 40. Sin theta is equal to cos theta. The given range covers the four quadrants. Sin theta equal to cos theta seems meaningless, but dividing both sides by cos theta makes it meaningful. So you divide both sides of this equation by cos theta. Why cos theta? Because we should know that if this place becomes sin theta over cos theta, that is tan theta, and here becomes 1, then you can get theta easily from that. So you have it in this form. To get theta, you take the inverse of tangent of both sides. So theta is equal to inverse of tangent of 1, and that is 45 degrees. This value is in the first quadrant. You check again the quadrant where tangent is positive, and that is the third quadrant, with formula 180 degrees plus theta. To get the other value of theta, you add it to 180. So theta again becomes 180 degrees plus 45 degrees, and that is 225 degrees. Following the given range, you have theta to be equal to 45 degrees and 225 degrees. Example 41. You have sin theta plus sin square theta equal to 0. This is quadratic in nature, and as such, you can factor out sin theta from the left hand side, and you have it in this form. You then equate each factor to 0, and you solve the solution for each factor. Taking sin theta equal to 0, to get theta from here, you take the inverse of both sides. Theta becomes 0 degree. You check the quadrant where sine is positive again, and that is the second quadrant with this formula. So you equate this to the 0 that you have earlier for you to get the other value of theta. So you have it in this form. If you simply transfer minus theta to the right hand side, it becomes positive. So you have theta equal to 180 degrees. For the second factor, you simply transfer 1 to the right hand side, it becomes negative. To get theta, you take the inverse of sine of both sides. This minus 1 is not for you to check the inverse of minus 1. It simply means that sine is negative. So you check the quadrant where sine is negative. Hence, the minus sign is written outside. And you check the inverse of sine of 1, and that is 90 degrees. Next thing is to check the other quadrants where sine is negative. That is the third and fourth quadrants with this angle for the third quadrant and this for the fourth quadrant. You equate each angle to the 90 degrees you obtained previously. You have it in this form. From here, theta is 90 degrees plus 180 degrees, and that is 270 degrees. And you equate the second angle to the same 90 degrees. You transfer minus theta to the right, it becomes positive. You transfer plus 90 degrees to the left, it becomes negative. After subtraction, theta is equal to 270 degrees. Hence, the values of theta between 0 degrees and 360 degrees are 0 degrees, the one you obtain from here. We have 90 degrees. There is also 180 degrees and 270 degrees. 4 values within the given range. Example 42, you have bracket open 2 cos theta plus 1 bracket close, another bracket open 1 minus cos theta bracket close equal to 0. Solution: no need to expand, as that will lead to more complexity. If you choose to expand, you're going to have a more complex equation. You simply equate each bracket to 0 and you have it in this form. Next thing is to do simple rearrangement. You transfer plus 1 to the right, it becomes minus 1. Here, if you transfer this term to the right, it becomes positive, and you have it in this form. For the first side, divide through by 2, and you have it in this form. You have to take the two sides and solve for theta respectively. So taking cos theta equal to minus 1 over 2, which is equal to minus 0.5. To get theta, take the inverse of cosine. This minus simply means you check other quadrants where cosine is negative. So you write it outside. If you check the inverse of cosine of 0.5, you have 60 degrees. These other values are from the other two quadrants where cosine is negative. That is the second and third quadrants. Taking cos theta equal to 1. To get theta from here, you simply take the inverse of cosine of both sides. you have it in this form, and that is 0 degrees. This other value is the other quadrant where cosine is positive apart from the first quadrant, and that is the fourth quadrant where cosine is positive. The angle there is 360 degrees minus theta. So if you equate it to 0 and you solve for theta, you have 360 degrees. Therefore, the values of theta are 0 degrees, 120 degrees, 240 degrees, and 360 degrees. Here, the values corresponding to 60 degrees are 120 degrees and 240 degrees. That is why we don't have 60 degrees here again, because 120 and 240 were obtained because of 60 degrees when we check the quadrants where cosine is negative. Example 43, solve this equation. Solution: you simply cross multiply and you have it in this form. Next thing is to collect like terms. This one is here. You transfer this, it becomes positive. You have 2 here. You transfer 1, it becomes negative. And you have 2 cos theta equal to 1. To get cos theta first, divide both sides by 2 and you have 0.5. You check the inverse of cosine of 0.5 in order to get theta, and you have 60 degrees. You check the other quadrant where cosine is positive, and that is the fourth quadrant with angle this. You equate this to the previous value for you to obtain the other value of theta, and you have 300 degrees. Hence, the value of theta in the given range are 60 degrees and 360 degrees. Example 44, you have the equation 8 sine squared theta plus 6 cos theta minus 9 equal to 0. Solution: we need to have the same trig ratios in the equation, and from the look of things, it is much more easier to replace sine squared theta. Now, let's recall one of the identities of sine squared theta plus cos squared theta equal to 1. In that identity, if you make sine squared theta the subject, you have this result. So you come here and replace it with this value, and you have this line. You expand this bracket using 8, and you have this result. Next thing is to add like terms. 8 minus 9, that is minus 1. What you have here is quadratic in nature. To make this coefficient to be positive, let us transfer all the terms to the right hand side. When you do that, you have it in this form. In order to have smooth solving, let us replace cos theta with m. You can use any variable of your choice, and you have this result. When you factorize by getting the two right factors, you have it in this form. The terms are 4. You group them in 2s in this form, you factor out the common term and you have this result. At this point, you equate each factor to 0 and you have it that 2m is equal to 1 or 4m is equal to 1. Divide both sides by 2 and 4 respectively. You have m to be equal to 1 over 2 or m is equal to 1 over 4. Let's go back to cos theta equal to m. When m is equal to 1 over 2, cos theta becomes 1 over 2 and that is 0.5. To get theta from here, you take the inverse of cosine of both sides. So theta is equal to inverse of cosine of 0.5 and that is 60 degrees first. You check the other quadrant where cosine is positive. Theta from that quadrant becomes 300 degrees. When m is equal to 1 over 4, cos theta becomes 1 over 4, which is 0.25. To get theta, you take the inverse of cosine of both sides and you have 75.520. 75.52 degrees. If you check the other quadrant, precisely the fourth quadrant where cosine is positive, you have the other value of theta to be 284.48 degrees. Hence, the values of theta within the given range are 60 degrees, 75.52 degrees, 248.48 degrees, and 300 degrees. Example 45, you have the equation 4 sine theta cos theta plus 2 cos theta minus 2 root 3 sine theta minus root 3 equal to 0. Solution: group like terms. When you do that, you have the first two terms to be the first group and the last two terms the other group. If you factor out the common terms from each group respectively, you have this result. At this point, you see that 2 sine theta plus 1 is common again. When you factor it out, the remaining two terms outside combine to give the other factor and you equate it to 0. You equate each factor to 0. When you transfer the respective constant terms, you have this result. When you divide each term through by 2, you have this result. So let us take the first one. Sine theta equal to minus 1 over 2, which is equivalent to minus 0.5. To get theta, you take the inverse of sine of both sides. You are not taking the inverse of sine of minus 0.5. This minus means you check the other quadrant where sine is negative. So you write the sign outside and check the inverse of sine of 0.5, and that is 30 degrees. So you check, okay, here is negative, here is negative. So sine is negative again in the third and fourth quadrant with angles theta minus 180 degrees and 360 degrees. With these two angles, we get the other values of theta corresponding to 30 degrees. The first result. From the last step, you equate the first angle to 30 degrees. When you solve for theta, you have 210 degrees. The other angle, you also equate it to 30 degrees, and when you solve for theta, you have 330 degrees. That is for when sine theta is equal to minus 0.5. We take the other solution, that is cos theta equal to root 3 over 2. You shape the inverse of cosine of both sides and you have this result. The inverse of cosine of root 3 over 2 is 60 degrees. Now, in the fourth quadrant, cosine is positive. If you equate the angle to 0, if you equate the angle to 30 degrees and you solve for theta, you have 360 degrees. Hence, the value of theta between 0 degrees and 360 degrees are 30 degrees, 210 degrees, and 330 degrees within the given range. End of lesson 10. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis. To avoid that, you have to give your life to the Lord Jesus Christ and confess Him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Find something good to do with your hands and brain, and the Lord will bless you. Goodbye and stay tuned.